Math 125, Units 7 and 8, Lesson on Sampling. So let's talk about sampling. We first need to understand the difference between a population and sample. Population data, this is the set of items that meet your specified criterion. For example, the population of the United States would be all the people living in the United States, whereas the population of Austin, let's say Austin, Texas, means all the people living within the city limits. Populations could also be sets of objects, such as all the houses built in Omaha, Nebraska in 2023. But a sample refers to only a subset or a small piece of elements chosen from a population. It's oftentimes difficult to reach an entire population, so the sample saves time, money, and there's other reasons why we would choose a sample over trying to get in touch with or find the entire population. So there are 4 types of sampling that we're going to cover in Units 7 and 8: simple random sampling, quota sampling, stratified sampling, and convenience sampling. Simple random sampling. This type of sampling occurs if a sample is drawn in such a way that each time an item is selected, each item has an equal chance of being drawn. So a real-world example of simple random sampling would be a raffle ticket is drawn by a blindfolded person at a festival to win a grand prize. So every single ticket that is in that bucket or in the hat has an equal chance of that blindfolded person choosing that raffle ticket. So that'd be simple random. There is a great video from IntelliPath on simple random sampling, and actually it goes into multiple different types of sampling. Quota sampling. This type of sampling selects a specific number of respondents based on how they are represented in the chosen population. So it's more of an economical type of sampling. For example, you design a high school homework survey that requires a sample of 50 boys and 50 girls, because that means that your population of the high school is super close to 50-50. So your quota, the sample you're taking, you want it to be that same ratio. And there's another great video from IntelliPath on quota sampling here. Stratified sampling. This type of sampling involves dividing the population by characteristics called stratifying factors, such as age, gender, race, religion, income. There's lots of different factors you could choose. For example, students at an elementary school are classified according to their present grade level. Then a random sample of 3 students from each grade are chosen to represent their class. Convenience sampling is a sample of individuals that are easy to reach. It does not represent the entire population. And this kind of sampling is subjected to probably the most bias. So it's important to know that it's very easy to perform a convenience sample as opposed to some of the other types of sampling that we've talked about, but it is subject to bias, more so than the others. So, for example, if I asked people standing outside an art museum if they liked art, we would probably expect that more than the general population would say yes. Or if I stand outside a coffee shop and ask people if they like coffee, or if I stand outside a water park and ask people if they have on sunscreen. So you can see how those answers would be not very representative of the entire population. 2 other types of sampling I wanted to quick talk about, just because you may run into it in your reading for this course or another course, would be systematic sampling and cluster sampling. So for systematic, when a sample is obtained by drawing every nth item on a list or production line, the sample is a systematic sample. If I were a cop and I wanted to do a checkpoint, maybe I stop every 10th car. That's systematic. A cluster sample is sometimes referred to as an area sample because it's frequently applied on a geographical basis. With cluster sampling, we first divide our population into groups or clusters. You could think maybe like voting districts. Then you obtain a simple random sample of a certain number of clusters from all of the possible clusters. And then finally you gather your data on every sampling unit in each of your randomly selected clusters.